All right, in this video, I'd like to look at another way that we can use factoring to help us solve equations. This one is actually, it's not quadratic, it's a literal equation, meaning it has many variables. It's like a formula, and we want to isolate a specific variable, in this case, p. And these can be a little bit tricky, but one of our goals in pre-calculus is to be able to see the simpler problem in something messier. Same thing with calculus, to kind of be able to train our minds to focus on the right pieces. So here, if we're solving for p, it's really the only one that we're going to treat like our variable. Even though t and m are variables, in our head, we're going to pretend those are just numbers. So pretend that t is 2 and m is 7, for example, whatever you want. And we're going to solve just as if that was the case, which means basically right now we're just solving a linear equation. There's no powers on p. It's not stuck in any fraction denominators. It's not stuck under roots, nothing like that. So really, this is just a linear equation with more variables than we usually see. Okay, so if I want to solve for p, I want to kind of tune out the mess of the m and the t and just think about what's going on. And what jumps out at me is that I have p's on both sides of the equation, so that's going to be a really big priority to get p on one side. But I can't even quite jump into that because right now p is stuck on the left-hand side in the parentheses. So my first goal is to free my variable up from any mess. And mess can be it's stuck in a fraction, mess can be it's stuck under a root, or in this case, mess is that it's stuck in parentheses. There are two ways that I could see right now to quickly get rid of those parentheses. One would be to divide both sides by the t. I don't love that one though, because if you do that, you have to divide everything by t, which means over here, our p would then be stuck in a fraction. So, oh, hold on, I was supposed to hide from you because I don't like it. There we go. We don't want to do that because then we're just creating a different mess. The other option is to distribute the t into the parentheses. So we'll have mt minus pt equals m plus p. And I do think that's an improvement. The p is no longer stuck in parentheses. So now I can focus on isolating the p's on one side of the equation. You get your choice of which side of the equation it goes on. Your answer will look a little different. All your signs will be swapped depending on which side you put it on, but they're equivalent. They're the same answer. So I'm going to move my p's to the right side, which means I'll add a pt to both sides. And be very careful, p and pt can't be actually added together. They're not like terms. They don't have the exact same variable parts. So we'll leave the mt by itself. And on the right, we have an m plus a p plus a pt. So I'm happy that my p's are on one side, but I can't actually combine them. And I haven't even done a very good job of trying to isolate them yet. Before I go any further with the being able to combine them, I also want to work on moving the m to the left-hand side. That's a really easy step to get the p's more isolated. So I'm going to say I have mt minus m equals p plus pt. Okay, so this is where often people will get really stuck on this. If this was our usual type of linear equation, so just for example, if m was 2 and t was 7, is that what I said? I might have switched them, but close enough. I would be looking at this, and it would be really nice because I could just say, oh, well, p plus 7p is 8p, and over here I could say 14 minus 2 is 12, and then I would divide. But that's a lot trickier when you don't know what value t and m are supposed to have. So this is where factoring becomes really powerful in this equation. So it's not really at all like what we do for quadratics, where we use the zero product property. Multiplying two things and getting 0 means one must be 0. Here, it's really just a trick to help us isolate our variable. So the mt minus m is just fine. On the right-hand side, the way I get down to a single p is I factor. And I'm left with 1 plus t. And note, if we're thinking of the example down below, that's the same idea as, well, you add the coefficients to combine. So this is saying if I have 1 p and I have t p's, then how many p's total? 1 plus t of them. And now that I factored that out, this is attached by multiplication. It's a single it's a single p. If I want to get rid of the 1 plus t, I would eliminate it by dividing, right? So always using those inverse operations. So mt minus m over 1 plus t is equal to p. And that is a fantastic answer. Note that if you had decided to move your p's to the left, your answer would be similar but not quite the same. The mt would be negative and the m would be positive. And on the bottom, the 1 and the t would both be negative. So all signs switch. And it's really easy to check yourself because all you would have to do is multiply top and bottom by -1 and make sure that that gives you something if you're looking at an answer and it seems a little different. Of course, online homework will check that for you, hopefully correctly, but I do want you to recognize those are the same answer. Okay, hopefully that helps. Thanks for watching.